Hello, this is a podcast on your lab that you're going to be doing in AP Chemistry. Let's first review the lab that we just completed, and that lab was the standardization of sodium hydroxide. Now, the standardization of sodium hydroxide was a lab where you were trying to figure out what the concentration was of sodium hydroxide that you were titrating. So, just a simple little diagram explaining the point of the lab is that you had sodium hydroxide in your burette and you titrated it out into a flask, and in that flask you had a salt that you had dissolved in water. That salt was an acid which was KHP. Sodium hydroxide and KHP react together in a 1-to-1 ratio to produce NaKP and HOH, which is water. So which is a salt and water, hence it's an acid-base reaction. This was our base, this was the acid. So, just reviewing the analysis that you need to complete on the standardization of sodium hydroxide lab, what you have to do is you have to absolutely make sure that you know the volume of sodium hydroxide it took until it fully reacted with the KHP. You know it fully reacts when it turns pink because of the phenolphthalein. So, the math that you would do is that if you had 45 milliliters as your initial volume, and your final volume was, say, 20 milliliters for the sodium hydroxide, then if you take the difference between those two, you know the volume of the sodium hydroxide it took to react with the KHP. You obviously want to convert that into liters because all of these problems, of course, are going to be working with liters. So you have that many liters of sodium hydroxide, and you're trying to figure out its concentration. That's part of your given information. Now the KHP, you should have measured its mass. Now if you measured its mass and it was, say, 3.254 grams of KHP, you were given the molar mass for KHP where you could change it into moles of KHP. So, when you set up the calculation, you need to make sure that you have the molar mass for what you are titrating. The molar mass for this particular KHP is 204.22. So when you take in your calculator and you do your division, where it is 3.254 divided by 204.22, you end up with moles of KHP, which is somewhere around, I'm just going to round it off in this one, just so I can keep it simple, 0.016 moles. So this is just a sample problem. You want to maintain the same number of sig figs of KHP when you do your actual calculation. Now, we have to take these moles, and we know that it reacts in a 1-to-1 ratio with sodium hydroxide. So this is the same as 0.016 moles of NaOH. What that means is that when this turns pink, it means is you have the same amount of sodium hydroxide as you have KHP because they react together in a 1-to-1 ratio. All right? So now, you know the moles of NaOH, you know the liters of NaOH. Now you just have to figure out the molarity. And that's a simple division problem. You just take the moles divided by the liters because that's the definition of molarity, is it's the moles per liter. So you divide those two, and then you know your answer for the molarity for the sodium hydroxide. Now here's the good news. You're not going to have to standardize your sodium hydroxide when you come in to do the next lab. The next lab you're going to do is actually already going to be standardized for you. So you will know this information of what you're titrating. You know how much sodium hydroxide you actually have. Now what we're going to do is we're going to get into the next lab that you're going to be doing, which is going to be part of your test. And it's actually going to be written in your lab notebook, so you're going to actually have to write out the following information. So, the next lab that we're going to be doing is going to be titled the molar mass of a diprotic acid. So, this is what you're going to write in your table of contents. And it's also going to be the title of the lab once you write it actually in your lab notebook. The question for this particular lab is going to be, what is the molar mass of the diprotic acid? It's a pretty simple question. So when it comes to the background information that you're going to write down in your lab notebook, you're going to have to get down a lot of information. First off, you have to know the reaction that you're doing with the diprotic acid. So on our background, we're going to learn the notation that we'll use to refer to a diprotic acid. Let's first talk about the difference between monoprotic acids and diprotic acids. A classic example of a monoprotic acid would be hydrochloric acid. A diprotic acid would be H2SO4. Now, you'll notice that this has two hydrogens and this is one hydrogen. Mono, di. So since we don't know what the other part of the acid is, the Cl or the SO4 on this lab, what we're going to learn to do is we're going to learn to notate it differently. For monoprotic acids, we write HA. A, obviously for acid, but it's what else is bonded to the proton that makes it acidic. So for our diprotic acid lab, you're going to see this. So you don't know whether it's SO4, whether it's H2, whatever. It's some sort of acid, and you're trying to figure out its molar mass. So in your titration, there's going to be a chemical reaction between the acid and the base. You're titrating it with sodium hydroxide. So just as a quick little picture example that you do not need to write in your lab notebook, is that what's coming out here is going to be the NaOH, and what's going to be down here is going to be the HA. And if we measure the amount of NaOH it takes to react, it's H2A, to react with a diprotic acid, then we can actually do some math to figure out its molar mass. So the reaction would be H2A plus NaOH. It's an acid-base reaction. And what's going to happen is you're going to produce, of course, the salt, which is going to be the NaA, believe it or not, plus the HOH, which is your water. Now there's something that we have to be careful about with this. So sodium has a positive 1 charge. So let's look back at the H2A. The H2 and the A, well, we know the A has to be negative and the hydrogen will be positive because of our oxidation state rules. So if there's two positives for these two hydrogens, that means that the A has to be negative 2. If the A is negative 2, then I need two sodiums to fully react with it. So that means I need to balance my equation, so I put a 2 in front of there, and that's my chemical reaction, or that's the balanced chemical equation. Once I put a 2 here, it's totally balanced. That's the reaction that we're going to be doing when we have NaOH titrating down onto H2A. And we're trying to figure out what the molar mass is of this. That's the point of this lab, is what's the molar mass of the diprotic acid. All right, so let's talk about the procedures. It's going to be very, very, very similar to the previous lab, which was the standardization of the sodium hydroxide. So one of the cool things that we can do in this class is we can actually refer back to previous labs. So our procedures are actually going to say something about seeing the previous lab. So what you're going to do is write C, standardization of NaOH lab. And you're going to use the same procedures. So what that means, and this is not going to go in your lab notebook, what I'm about to write, we're going to actually do this on a set of notes, which is going to be LE, finding molar mass from titration. So remember in that lab, the standardization of sodium hydroxide, you had a cup, you had the acid in the cup, you poured it into a flask, and then you subtracted away the mass of the cup, and then you knew the mass of your acid. In the case for this lab, our acid's going to be H2A. You will already have the cups with the acid already present. So all you got to do is you got to just take the cup with the acid, drop it into the flask, and then you want to dilute it with water, the same volume as the sodium hydroxide lab. All right? Then you begin your titration. but this time you actually know the concentration of the sodium hydroxide. So this guy is being titrated into a flask which has your unknown H2A. The base that you're going to be titrating it with, sodium hydroxide, is of a 0.01 molar concentration. Let's write that in our procedures. So back to our lab notebook. In our procedures, you're going to write that the sodium hydroxide is 0.01 molar. That's the concentration of your sodium hydroxide. Okay? Now what you're going to have to do is you're going to have to figure out the molar mass. And the only way you're going to figure out the molar mass is knowing the mass of the acid plus the moles of the acid. So, as you titrate it down, what you're going to end up doing is you're going to end up having to do a series of calculations. Now, you have to know the equation for the reaction to be able to identify the amount of moles of this. So, when you're going to measure the volume, you'll have your initial volume, and then you'll have your final volume. And then from the difference between these two, you're actually going to know the volume of sodium hydroxide it took until it totally reacted with the H2A. So let's talk about the analysis that you would do. The analysis requires you to know that you have H2A reacting with 2 sodium hydroxides to produce Na2A plus 2 HOH. Okay? So let's imagine some data. The data that you would have is you would know exactly the volume that it took. So say it took 0.02 liters of this. Well, if it's 0.02 liters of the sodium hydroxide, and you know its concentration is 0.01 molarity for the sodium hydroxide, all you have to do is multiply these two numbers, because don't forget that this is the same as moles over liters. So if I multiply it by the 0.02 liters, liters cancel out and I'm left with my moles. So once you've done that math, then you're going to end up with a specific amount of moles of sodium hydroxide it took to actually balance the two out. Now, hopefully all of us in this class, let me move this back so you can see it for a second. So hopefully all of us in this class can do the math and know that the math between these two, when you multiply 2 decimals, becomes even smaller of a number. So we actually end up with 2 times 10 to the -4th in this example problem, moles of sodium hydroxide. Now, I now know how many moles of this I have. I have to figure out how many moles of this it reacted with. Well, if you stop titrating when it turned pink, then you know exactly the amount of moles of H2A that you have left. So the math that we would do is we take the moles of sodium hydroxide and change it into moles of the H2A. So don't forget that the numbers that I'm writing in this conversion factor right here, which is my mole ratio, are coming from the chemical equation. The moles of NaOH cancel out, and I'm left purely with moles of H2A. So now I have 1 times 10 to the -4 moles H2A, and from a previous step in the lab you had to measure the grams of the HOA. Say you ended up with 3.25 grams of H2A. Well, if you're going to figure out the molar mass, we should all know that molar mass is grams per mole. So it would be 3.25 grams H2A divided by the amount of moles. And that would tell you the molar mass. And that's the answer for your lab when you get to it. So this should have all been written in your notes. You are not allowed to use this on your test. I'm going to flip through your lab notebook to make sure that you did not write this ahead of time in your lab notebook. You must show your work leading to the answer. This is what I consider an advanced question on your test. Because it is an advanced question on your test, I'm going to make sure that you collect the data with your lab partner, but this analysis you're going to perform on your own, and I've given you notes that you can use to study before the test. Now, back to the actual lab that we wrote out. So we wrote out the question, the background, then after that we have the procedures. And that's it for the procedures. You can write data right below it, and the data that you should have in your lab notebook is you should have the mass of the cup plus the acid, which is the H2A, as data. You should obviously have the mass of the cup after you poured it into the flask. You should write down the volume of the solution that you diluted it with, so the volume of water added to H2A, and of course it's going to be the same as you added to the acid in the previous lab. The other data that you're going to record is you're going to have the initial volume of NaOH, and then you're going to have your final volume of NaOH. And that will be enough data for you to do the analysis. If you have any questions, please email me about this, obviously before I leave work on Thursday. Good luck. Make sure you've written up again, the question, the background, the procedures, and sketched out the data that you'll be needing to collect. Good luck.